All right, let's get right into it. We're about to crack a case that costs supermarkets billions. Yeah, billions of dollars every single year. Food waste. You know, it's this huge everyday problem that we all see. But as we're about to find out, the solution is this really fascinating story about the power of machine learning. So, at the very heart of this whole case, you've got this clear conflict. For decades, right, ordering fresh food has been all about guesswork, about a manager's gut feeling. But what happens when you swap that intuition for intelligent, data-driven prediction? Well, the results are, honestly, a total game changer. So, here's our game plan for this explainer. We're going to start with the problem itself. Then we'll look at the actual blueprint for the machine learning solution. After that, we'll see how it was tested, uncover a really dangerous hidden risk, and finally, we'll look at what all this means for the future of the fresh food aisle. Okay, let's kick off our investigation by setting the scene. The crime here, it's just massive inefficiency. The victim, all that fresh produce. And the cost? Well, retailers have a word for it. They call it shrinkage. And trust me, it is enormous. You know, the old method is so simple. A manager might just look at what sold last Tuesday and then order about the same amount for this Tuesday. It's called a moving average. But here's the thing. This approach is kind of a blunt instrument, and it almost always leads to one of two really bad outcomes, either piles of wasted food or frustrated customers like you and me staring at empty shelves. So why is this the perfect case for machine learning? Well, it really boils down to three key things. First, the problem is just incredibly complex. Demand for fresh food isn't a straight line, right? It's pushed and pulled by everything from a sunny weekend to a competitor's big sale. Second, there's a literal treasure trove of data just sitting there, waiting to be analyzed. And finally, the business impact is just huge. In the grocery world, profit margins are razor thin, so even a tiny reduction in waste makes a massive difference to the bottom line. So now that we've established the motive and the opportunity, it's time to actually look at the evidence. Let's dig into the blueprint for the solution, which was designed by data scientist Chau Dang. And the mission? It was crystal clear, and it was super specific. Create a system that could predict exactly how much of each of those high waste items, we're talking about things like berries, salads, avocados, would sell in every single store for a full week in advance. Okay, so how do you even know if you're succeeding? Well, you use a special metric called WEIP. Now that W stands for weighted, and that is the most crucial part here. It basically means the model gets graded more harshly if it gets the banana forecast wrong than if it messes up on, say, dragon fruit. And why is that? It's because getting the high-volume stuff right has a much bigger impact on the business. Now, to make these amazing predictions, the model needs clues. And this slide really breaks down the two types of evidence it's looking at. You've got internal factors, like price changes and promotions, and then you have external factors, like the local weather forecast, because let's be honest, nobody's buying salad ingredients in a ring storm, or even what the competition is up to. The system itself was designed for pure efficiency. It runs on the cloud, so it can pull in all that central data and tap into external weather info. It makes all its predictions in one big batch at 4 in the morning, right before the managers place their daily orders. And it only retrains once a week, which is just the right sweet spot. It's frequent enough to catch new trends without becoming unstable. Okay, so you've built your high-tech detective, but you can't just let it loose on the case, right? No way. You have to interrogate it first. This whole validation stage is all about making sure that the model can actually be trusted. This interrogation plan had 3 absolutely critical steps. First, backtesting. You look back at old data and see if the model would have correctly predicted, say, a past holiday rush. Second, a silent pilot. You run the model in a few stores, but you don't use its advice yet. You just watch it, and you compare its predictions to what the manager actually ordered. And finally, the live A/B test. You pit 10 AI-assisted stores against 10 human-only stores to see who really comes out on top. The result, by the way? A stunning 15% reduction in waste for the stores using the AI. But during this whole investigation, a hidden danger was uncovered. A really subtle but potentially deadly risk that could cause the entire system to fail, and fail in a catastrophic way. So, what do you think is the single biggest risk here? It's not about the model being wrong just one time. It's about the model accidentally teaching itself to be wrong over and over again. This risk actually has a name. It's called censored demand, and it's a particularly nasty kind of feedback loop. Let me just walk you through how it works. It all starts with a simple little mistake. The model, for whatever reason, predicts you'll sell fewer avocados than people actually want to buy. So, because of that bad forecast, the store doesn't order enough. The avocados completely sell out by 2 p.m., leaving the shelves totally empty for the rest of the day. And here is the crucial part, the part that makes it all go wrong. The sales data for that day shows a low number of avocados sold, not because demand was low, but because the supply ran out. So when the model retrains itself on this new data, it thinks, oh, I was right, demand is dropping, and it predicts even less for the next time. And that is the death spiral. The solution they came up with is just incredibly clever. Instead of blindly trusting that flawed sales data, the system now flags any day an item's inventory hits 0. And for those days, it doesn't use the capped sales number. Instead, it uses statistical methods to estimate what the true, uncensored demand actually was. And just like that, it breaks the feedback loop. And with that final, brilliant piece of the puzzle, the case is officially cracked. So let's just take a moment to look at the impact and the kind of future this kind of thinking creates. This quote from the project's lead, Chau Dang, really just says it all, doesn't it? The whole goal is to move from this old world of guesswork and gut feelings to a new world of precise, data-driven decisions. And, this has a real effect on all of us. The next time you walk into a supermarket and you find exactly the fresh berries you were looking for, not too few, not too many, you'll know it's not just magic. It's the result of this incredibly smart, data-driven system humming away behind the scenes. Which really just leaves us with one final thought. We've just seen how complex data analysis can solve a massive, real-world problem like food waste. So the real question is, what other hidden inefficiencies in our everyday world are just waiting for their own data-driven solution?